In this series of videos, we will look at the motion of objects and try to understand how they move. We will define what motion is and determine the laws of physics that govern the behavior of moving objects. Using these laws, we can then predict the future motion of such objects. To start off with, we will look at motion in a straight line or motion in one dimension. Let's start with the 100-meter sprint at the Berlin World Championships in 2009.
There is the full lineup. Every single one of the men in this lineup has run 100 meters in less than 10 seconds. Bolt, Gay, Powell, 4, 5 and 6. They're away. Terrific start by Daniel Bailey. Usain Bolt, though, getting into his running. Here he comes. Usain Bolt, challenged by Tyson Gay. Usain Bolt, 2 clear meters. Tyson Gay in second place. And in third place, the Safa Power.
9.58! Smashing the world record. Unbelievable! He's done it again. A year later, rewriting the world record again.
And here is the photograph that will flash around the whole of the world. You'll see it everywhere. New world record, 9.58. And there's the great man, Usain Bolt.
That was a clip of Usain Bolt at the World Championships in Berlin in 2009, where he broke the world record for the 100-meter sprint, running in a time of 9.58 seconds. So how fast did he run? When we ask how fast is something moving, we are referring to the rate at which it moves, or its speed. Speed is defined as the total distance travelled divided by the time taken to travel that distance. Since distance is a measure of length, it has a unit of meters, and time has units of seconds. So the dimension or unit for speed is meters per second. In Usain's case, he ran 100 meters in 9.58 seconds. So on average, his speed, or the rate at which he moves, is 10.4 meters every second, or 10.4 meters per second. There is another term used to define the rate of motion, and that term is velocity. Velocity and speed are often used interchangeably because both describe the rate of motion. But in physics, there are two distinct differences. The first is that velocity is only interested in the distance from the starting point to the end point. This is called the displacement. It is not interested in the actual path taken to get from the start to the end. The second difference is that speed is only concerned with the magnitude of the motion and does not say anything about the direction of the motion, whereas velocity tells us how fast the object is moving as well as the direction in which it is moving. Let's have a look at these differences in more detail. Consider Usain running 100 meters in a straight line moving forward to the right. He does this in 9.58 seconds, so his speed is 10.4 meters per second. But so is his velocity, because the distance he covers is the same as the displacement between the starting point and the end point. Now imagine that instead of a straight 100-meter track, he runs a loop that is 600 meters long and ends at 100 meters ahead of where he started. So he runs a total distance of 700 meters in 9.58 seconds, which is very fast, as we will see why. So for speed, because he has covered 700 meters in 9.58 seconds, his speed is 73.1 meters per second, which is much faster than the 10.4 meters per second previously. However, for velocity, his displacement, which is the difference between the start and the end point, is only 100 meters to the right. So his velocity is only 10.4 meters per second. So in this case, his speed is 7 times greater than his velocity in magnitude. Now let's have a look at the other difference, which has to do with direction. So we've defined average velocity as the displacement over the time taken. Displacement is defined as the difference between the start point and the end point. The formula for average velocity can be written as v bar being equal to delta x divided by delta t, where delta x represents the difference between the final and initial positions, and delta t represents the difference between the final and initial times. The horizontal bar above the V means average. Let's take the following example. Now, if Usain started at a different position and ran around the track but stopped 100 meters behind the starting point, we will define his starting point as the origin and the direction to the right as positive. That is, any position to the right of the starting point will be positive displacement, and any position to the left of the starting point will be negative displacement. So he runs a total distance of 500 meters in a time of 9.58 seconds. Thus, his speed is 52.2 meters per second. But because he stopped 100 meters of his starting point, his final position is to the left of the origin, and thus his displacement is minus 100 meters. Therefore, his velocity is minus 10.4 meters per second. So to summarize the difference between speed and velocity, both define rates of motion. But speed is defined as the total distance traveled over the time taken, while velocity is defined as the displacement over the time taken. Displacement is the distance between the start and the end point. Speed is only interested in the magnitude of the rate of motion, whereas with velocity, the direction also matters. Any quantity that can be described by the magnitude alone is called a scalar quantity, while quantities that require both the magnitude and the direction to describe it are called vectors. In summary, average velocity is defined as the displacement divided by the time taken. It has the units of meters per second. It requires both the magnitude as well as the direction to fully describe the quantity. Such quantities are called vectors. Before the video finishes, have a go at the following quick quizzes.